Lesson 5.2 is on proportions, being able to set up proportions, and determining whether ratios form a proportion. Now, there's two different strategies that I'm going to teach you in determining if two ratios form a proportion. One is to use equivalent ratios, or mental math, and the other is to use the cross products property, and I will go through both of those, okay? So, just starting to determine what a proportion is, okay? A proportion is an equation, so there's going to be an equal sign in the middle, stating that two rates are equivalent. Now, we talked about rates in the last lesson, right? A rate was a ratio of two quantities with different units, okay? So, here is what we're going to be seeing today, all right? We have two rates, okay? I have 1/2 and 5/10, and our job is to determine, do those form a proportion, yes or no? So there's a couple different strategies that we can use. My mental math strategy that I'll show you right away, okay? You're gonna ask yourself, all right, is there a number that I can multiply 1 by to get to 5? That number is 5, so I can take 1 times 5 to get to 5. Now, if these rates are going to form a proportion, if I take 1 times 5, I better be able to take the bottom number times 5 and get the correct number on this side. Well, 2 times 5 is 10, 1 times 5 is 5, so those are both true, so then you would say yes, they form a proportion. All right, another way to determine if two rates form a proportion is to use the cross products property. Cross products means you're going to multiply diagonals. So 1 times 10 is 10, 1 times 10 is 10, 5 times 2 is 10. Now, if these two numbers equal each other, which they do, then you will say yes. So you could have done that either way, using the mental math or the cross products. Your answer, regardless, was going to be yes. Those two rates formed a proportion. All right, let's see if 4/6 and 18/24. Let's see if these two rates form a proportion. Now, mental math doesn't work all the time, all right? So that's why it's important to be able to know both. I don't really know what 4 times a number is off the top of my head to get to 18, because there's not a whole number. But can we take 6 times a number and get to 24? Well, we can take 6 times 4 to get to 24, right? So 6 times 4. Now, if this is going to form a proportion, this top number, which is 4, we need to be able to multiply it by 4 as well to get to this number. 6 times 4 is 24, but is 4 times 4 18? 4 times 4 is 16, so it does not equal 18, so then you would say no, this is not a proportion. Now, if you didn't see that mental math-wise and you wanted to look at the cross products, you would take 24 times 4 and 6 times 18, okay? 24 times 4 is 96, and 6 times 18 is 108. Since those two numbers did not equal each other, right, you would say no, okay? So either way, you could go about that. Seeing that you took 6 times 4 to get 24, but 4 times 4 was not 18, so then you would have said no, or cross products, knowing these two numbers do not equal each other, you would say no as well. All right, last example. Here, 3 times what number is 6? Well, we know 3 times 2 is 6. Now, since I went left to right, I got to go left to right again. 3 times 2 is 6, now is 10 times 2, 5. You need to be careful on this, right, because this can be a little bit tricky. 10 times 2 is not 5. Now, 5 times 2 is 10, okay? But you cannot take left, going from left to right on the bottom, and then going from right to left on the top. So if I went 3 times 2 is 6, you have to go left to right again on the top and take 10 times 2. And since 10 times 2 is not 5, our answer would be no. Or once again, we could also take 6 times 10, which is 60, and 3 times 5, which is 15, and those two numbers do not equal each other. So either way, your answer would be no. All right, if we have a table and it tells you to determine whether the x and y are proportional, they have to be proportional the same all the way through, okay? If they're the same the most part and it's just off a little bit at the end or at the beginning, you would have to say no. So it has to be the same all the way through. So what I would do is you ask yourself, how'd you get from X to Y? How'd you get from 1 to 12? Well, we took 1 times 12 to get 12. So in this case, we're taking our X times 12, X times 12 will equal our Y, okay? So 1 times 12 is 12, okay? 2 times 12 is at 24, so that's good, it matches up so far. 4 times 12 is 48, and 6 times 12 is 72. So since those stayed proportional all the way through, you would say, yes, those are proportional, okay? And your last example that you're gonna see is it's gonna tell you to determine whether the two rates form a proportion. So we need to kind of set these up into a problem that looks kind of like these up here. All right, so I have 7 inches in 9 hours. So I'm gonna put 7 inches over 9 hours, okay? And then I'm gonna write my next scenario, 42 inches. So I'm gonna put 54 hours down here. So since I put inches on top here, hours on the bottom, I need to put inches on top, hours on the bottom. We gotta stay consistent. Now, we just need to figure out if these two form a proportion. Well, we can try mental math. Is there a number we can take 7 times to get 42? Well, 7 times 6 is 42. So if these form a proportion, I better also be able to take 9 times 6 and get 54. And since 9 times 6 is 54, and 7 times 6 is 42, then we say, yes, these are a proportion, okay? We could also cross-reduce, if you wanted to do that, and take 7 times 54, and that's gonna get us 378, and then 9 times 42 also gets us 378, and since those two is equal, that's why it was yes. All right, last example. 440 calories over 4 servings, and then 300 calories over 3 servings, okay? Now I really don't have a number to multiply 300 by to get 440 or 3 by to get 4, so this is where we just have to use cross products, okay? 440 times 3 is going to get us 1,320, and 4 times 300 is going to get us 1,200. Close, but those do not equal each other, so they do not form a proportion. So your answer is no. Okay? So you're going to have to determine whether the rates form a proportion. The ratios form a proportion. Remember, you can use your mental math strategy. If that's not working, you can always use your cross products rule. Multiply your diagonals. If they equal each other, you say yes. If they do not equal each other, you say no.
Justine Bierman, please come to the office.
So our homework
Justine
is on
Bierman.
page 174. You're going to do 6 through 22 evens.